In this experiment, students are going to make a biodegradable capsule. So we're connecting to the idea of biopolymers, thinking about how you can make a material that is designed to degrade. And that's going to be a really important thing for our sustainable future. So this biodegradable capsules, we've had lots of fun trying to get this one to work. Sometimes it works, sometimes it doesn't. It's really messy, but it is a lot of fun. Students really like playing and prodding with what they make and thinking about what they could be used for. Essentially, we're going to be making these from something that could be edible. The ones that we make in the lab are definitely not. After all, we're doing it in the lab, so we wouldn't want to eat them. But there are things you could do to make this one that the students could eat them, and I'll talk about that at the end. So in the version that we're putting here in the video, we take two things. We're going to have our sodium alginate. So sodium alginate basically comes from algae or kelp, essentially seaweed. So, and the other one is going to be our calcium chloride. So you could use calcium lactate, and calcium lactate would come from milk solids, or calcium chloride. Again, the calcium's coming from there, but calcium chloride is a fairly easily sourced material. And really, this is going to be a very weakly, we're going to sort of an ion displacement, that when we allow these two to mix, they're going to want to form a polymer. But those layers, what's going to happen here is that we're going to, the calcium's going to come in, displace the sodium, and that's going to cause sort of a weakly ionic dispersion that's causing those layers to sort of come together. And I've described that very simply. You could, there's a bit more online about this. There's a fantastic paper written by the research group of Professor Jane Wissinger, where they've made these calcium alginate beads, and I think it's a really nice one to go look at. And there's another full method there. The method that we're putting here is essentially this. We're going to dissolve about 4 grams to a litre in our sodium alginate solution. This is really important. Use a blender. You've really got to blend this thing and to get it to really mix properly and form a consistent solution. So what I do is I get my water in my blender. I'll put a bit of food dye because it's nice to have a colour. Any colour will do. And then when I'm ready, get the blender going and slowly pour in the sodium alginate. I'm going to let that blend for a good 30 seconds, turn it off, pour the solution into a beaker or whatever you're going to use to store for the time being. And then that's got to rest at least 30 minutes, ideally a few hours, because what we want to do is all those air bubbles, we want to get all those air bubbles out of that solution so it's ready to go. Our second solution is much more simple. It's just going to be some, 4 grams per litre seems to work, a mix of calcium chloride and water. So if you are pressed for time, you could make that solution ahead of time for the students, or the students could get a 250 ml beaker or a cup, put 1 gram of calcium chloride in, stir it, and they're ready to go. So when you're ready, this bit's quite simple, but it can get messy depending on if your concentrations are about right. Is you're going to get we use these 1 tablespoon plastic cups, plastic spoons, and then we lift out, so you pick up some of the sodium alginate solution, you're going to slowly lower it into the calcium chloride solution. Try not to disturb it as much as you can, and then flip it over, and then wait 5, 10, 20 seconds, and then lift the spoon out, and then hopefully your sodium alginate is going to stay inside the cup. It takes a few goes. The ones you see in the video were not my best ones, but you'll see, and then you just need to wait. So what's happening there is we've got the calcium calcium entering into the water coming in, and we're going to have sort of a bit of a layer on the outside and water being kept on the inside, and so that's going to be our capsule. Wait good 10-15 minutes, but pretty much straight away you can look at it and you can see that these look quite rounded capsules. And then when you're ready, you can just lift them out. I like to put them on a watch glass for a little while, just prod them a little. If you got your concentrations right, when you're ready, you can lift it up and hold it in your hands. And you can sort of just touch it a bit, it feels a bit clumpy. But then if you notice you cut it or if you sort of pull it apart, you'll see that there was some water inside. And that's what made these capsules as opposed to just a big clump of gelatinous mass. There was actually water inside these. And so that's a really interesting way of talking about this. Why? Why is this useful? Well, think about all of those single-use small packaging that we have in our consumer society. I'm talking about little bits of tomato sauce or mayonnaise, ketchup if you're American, or even little soy sauce packets and all sorts of things. Think about things that we regularly have when we go outside for things. We use it once, and what do we do with that thing? We throw it in the bin. But that might have been made out of traditional plastic, or it might have had some metal lining to it. And so that thing is going to go into rubbish, and it will take hundreds and thousands of years to decompose. If we only needed it to really hold its shape for a little while, why not use something like this? So other innovators are looking at this at the moment, making sort of super simple biopolymers that, can hold a liquid on the inside. You use it once and you throw it out, and then that's going to degrade much quicker. And so whilst the one you make today probably isn't good enough to, sit in your lunchbox and be used the next day, but, it shows the principle of what we're trying to do. And maybe then you can show some videos you find online. I won't name any particular industry companies, but, there's a few companies online that you can see what they're doing for this. There's a fantastic video you'll find of them being trialed at I think it was the New York Marathon, and then people, rather than having to, because they're food safe, if you make them out of an alginate and a lactate solution, you could just eat them. You could eat the whole thing, and you get the water that way. Now, you and your students might be wondering how to make this completely 100% food safe, because you want the students eating them. Well, first of all, get out of the lab. Do it somewhere else. Do it in another classroom. No beakers, no spatulas. Use plastic cups. And for your consumables, our sodium alginate and our calcium chloride or our calcium lactate, source these from a food store. So a store that sells, additives or foodstuffs. You might find them online if you can, and then you can use those. And if they've come from a food grade store, these are edible. And so when the students make them, they could eat them if they want. If you make them with calcium chloride, they'll be a little salty. Calcium lactate, very neutral flavor. But it's, I think, just being able to play and prod with them and notice the water that's inside them if you do them properly. I think